Alright, hello class. In this video we're going to derive all the graphs for the inverse trig functions. I'm just going to go through it quickly so the video is not ridiculously long, so if you want to, you can pause the video as I go between different graphs. Alright, so as we said, there's certain restrictions we're going to have with sine inverse, cosine inverse, all of that, right? If you need to review those, look at the previous video about evaluating inverse trig functions, then come back to here. But basically, we're going to have to restrict them. I restricted these in the previous video, and I just redid them in red over here, so the sine graph, restricting it that way. So essentially how that's going to look is, at 1, we're going to have pi over 2. At, negative 1, you're going to have negative pi over 2 as your output, and then you're just going to essentially have the sine graph going throughout. So notice that this is the same as that little shape that I did over here. It's just inverted this way, right? Because when you have an inverse, essentially, if you reflect it over this line, you get the graph of it. So if you know sine, you can get sine inverse this way. So pause if you need. I'm moving on right now. Alright, cosine inverse, very similar thing. So we'll see that at negative 1 corresponds with pi. 1 corresponds with 0. And then 0 corresponds with pi over 2. So essentially, we get this kind of a graph going on. So again, if you can do this, you can do that. It's kind of just like this in a way. Alright, I'm moving on to the next one now. Okay. So we have two asymptotes here. That's going to be at pi over 2 and a negative pi over 2. So essentially, tangent is just going to fit inside of here. For 1, we get... Oops, I did that a little bit too high. I thought something looked weird. Okay, at 1, the angle is pi over 4. At 0, the angle is 0. At negative 1, the angle is negative pi over 4. So with those reference points, you're able to just go through like that. Alright, I am moving on to the next one now, so pause if you need to. Alright, cosecant. So we have an asymptote going through at 0. Yeah, there are some anchor points. We have pi over 2 and 1. Those are related. Negative pi over 2 and a negative 1. And then the thing just curves toward the asymptote. So notice that pattern. And then also notice, I'm just going to dot in real fast. This is the sine inverse graph. So if you notice that there's that, you can actually draw them together. That might actually help. Secant, is going to be very similar. Sorry, I just dropped my pen. Secant has an asymptote instead, though, at pi over 2. And then it'll be negative 1 at pi and 1 at 0. And I just, again, go toward the asymptote. And just dotting in, this is the cosine inverse graph. That can help you. Alright, moving on to the next one now. Here, yet again, we got two asymptotes. They're at pi and 0. And then here's the center. Then we got those points going on. So it looks almost like the tangent inverse graph, but not exactly. Slightly different. This is what tangent inverse would look like. So I'm just going to dot that in. So notice that they're not exactly like, again, like chromosomes like that. Instead, they're kind of shifted over a bit from each other, and then you see like some shifting both left and right and up and down. So notice that that's a difference. So don't try to draw them chromosome-like, because that's not correct, and therefore you will lose points and stuff. And is oversimplification, which is not good. Alright, so this is what they all look like. Memorize them, understand the pattern, really. There are different patterns that exist within them. I've shown you a lot of those patterns. So look at them, look for even more patterns that I might not have even noticed or mentioned at all. And we will learn how to transform these and practice with that in future videos.